I'm Rajesh Uppal, Director IDST. We bring sharp insights and foresight on defense, security, and emerging tech. Let's dive in.
Imagine a light source so precise, so stable, and so efficient that it could transform everything from global internet speeds to life-saving medical imaging. That's the promise of quantum dot lasers, a leap forward in photonics that could reshape industries and even redefine daily life. So what makes them so revolutionary? At the heart of this technology are quantum dots, nanoscale semiconductor crystals just a few nanometers across. Think of them as artificial atoms. When energized, they emit light at very specific colors, not determined by the material, but by their size. Adjust the dot size, and you can tune the light with atomic-level precision. That's quantum physics in action, and it's what gives these lasers their extraordinary versatility. Traditional semiconductor lasers have powered our communications and devices for decades, but they come with trade-offs: high power demands, instability under temperature shifts, and limited control over wavelength. Quantum dot lasers solve these challenges. By confining electrons in all three spatial dimensions, they create discrete, atom-like energy states. The result? Lower energy thresholds, remarkable thermal stability, and laser beams that are sharper, more reliable, and easier to tune. Now, let's talk applications, because this isn't just theory. In telecommunications, quantum dot lasers are natural fits for fiber optics. They emit at the ideal wavelength to carry data over thousands of kilometers with minimal loss. Their spectral stability means they can pack more information into the same fiber, fueling internet speeds 100 times faster than today, powered by lasers smaller than a grain of dust. In medicine, the impact is just as profound. Surgeons can use quantum dot lasers for ultra-precise procedures, reducing collateral damage to healthy tissue. In diagnostics, they enable advanced imaging techniques like optical coherence tomography, revealing disease earlier and with greater accuracy. Because their emission can be tuned so finely, they can even target specific molecules or tissues, opening new frontiers in personalized medicine and phototherapy. And then there's LiDAR, the sensing backbone of autonomous cars, drones, and robotics. Quantum dot lasers deliver stable, eye-safe beams across long ranges and in extreme temperatures. That reliability could make self-driving cars safer and industrial sensing far more accurate. From mapping city streets to tracking pollution, these lasers expand the reach of real-time monitoring. Even consumer electronics are poised for disruption. Imagine augmented reality headsets with brighter, more vivid colors, or pocket-sized projectors that display cinema-quality images on any surface. Quantum dot lasers could bring that future within reach. But how are these remarkable devices actually made? The answer lies in advanced nanofabrication. The traditional approach is molecular beam epitaxy, an ultra-precise method that grows materials layer by layer in a vacuum, producing near-perfect quantum dots, but at high cost and slow throughput. To solve that, researchers are turning to metal organic chemical vapor deposition, or MOCVD, which scales up production while retaining the necessary quality. Recent breakthroughs, like those from research institutes in South Korea, have cut costs dramatically while achieving record performance, paving the way for mass market adoption. Of course, challenges remain. Yields are still lower than conventional laser diodes. Long-term reliability testing is ongoing, and pushing quantum dot lasers into visible or ultraviolet ranges requires solving difficult material science puzzles. Yet progress is accelerating, and each year brings solutions closer. Looking ahead, integration with silicon photonics may be the biggest leap. Entire optical circuits, lasers, modulators, and detectors could be fabricated on a single chip, enabling cheaper, faster, and more compact systems for data centers, medical devices, and defense. Researchers are also exploring electrically pumped visible light quantum dot lasers, which could revolutionize next-generation displays and holography. The big picture is clear. Quantum dot lasers are not just an incremental upgrade, they're a platform technology, like the transistor or the LED, that unlocks entirely new possibilities across science, industry, and consumer life. From powering the Internet of the future to transforming medicine, transportation, and entertainment, they embody the next leap in our mastery of light. Thanks for watching. Subscribe, follow, or visit idsth.com for more cutting-edge defense and tech insights. See you in the next one.